Hey everybody, this is Larry. This is day 25th. Yeah, of the Leetcode Day Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem. I was just double checking whether the weekly poem is up. Today's work poem is, I'm gonna sneeze, hang on. As you can see, allergies are still plaguing me. Yeah, today's poem is going to be 140 word break 2. I am going to do the extra poem later, but maybe a little bit later than usual because I'm in between the Rangers game right now. They're tied at 1 and going into the third period, so hopefully wish Rangers good luck. Okay, let's take a look. Word break 2. Given a string S in a dictionary word dig, add spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentence in any order. Note that the same word in the dictionary may be reused multiple times in a segmentation. Yeah, this is one of those poems that are once again going to be exponential in output. I do actually vaguely remember this one. I did this one, or maybe a variation on this one, where Leetcode is just really bad about it. I don't know if they fixed it or not, but one of them they were just like, oh, you have to do this one very specific optimization, and if you don't do it, then it doesn't work, which is kind of awkward because it's like mind reading a little bit. And this is an NP problem, right? And not even that. Yes, that, but even the output could be exponential, right? So given that there's 1,000 words, s dot length. S dot length is 20. Okay, so maybe I'm thinking of something else. Maybe, I don't know. Huh. Okay, maybe I take it back a little bit. Maybe there is a different variation because I feel like there is one where it's a little bit awkward, but yeah. I mean, the situation is that the size of the output is exponential, right? So that means that there's really because the size of the output is exponential, that means that the algorithm can really run faster than exponential. You have to generate the output in the time it takes to, to put it into, to allocate the space for it, if nothing else, right? And then, even if you fill with blanks or something, right? So, okay. Yeah, so the key thing to note is that s dot length is 20, so maybe I was thinking of another poem, and that makes it, of course, only 2 to the 19 gaps, or spaces, if you will. So that means that it should be okay. So basically, we're doing the same thing that we're doing the last couple of days. So maybe we just do a construct. We have an index on the S. We put an index is on S. And yeah, and then we just do a for loop to check if they're in the word dictionary, right? Yeah, and I think that's all the states that. Oh well, I mean, and maybe like current for the current set of words. Yeah, that should be okay, maybe. And current is the current set of prefixes, right? So I do want to go over something really quickly. Let me write the base case, then we just return. Maybe we have something like answer and then answer dot append space, right, something like that. But yeah, so I'm going to write it this way, where for n is in range from index n, right? And then we can do something like if s of index to n plus 1 is in word dict. Oh, I forgot that they gave it to us in a list. Even though it's called a dict, I guess dict is dictionary, but it's a little bit, yeah. Okay, so then maybe we'll just have d is equal to a set of word dict, and then this is just d. Right, if this is in D, then we can do construct or current dot append, right? And in between, we will do construct index plus not plus 1, plus length of, or plus n minus index. Oh, what am I doing? Because, yeah. I am, yeah. And that's pretty much it, right? So then now we construct 0 empty array, and then we return answer maybe, right? We'll give it a quick see to see if it works. Okay, looks okay. Give it a submit. Oh, why did I get time limit in the past? I am curious what I did in the past too. Not quite sure why this time limits, but nowadays it is a little bit faster, apparently. I don't know. I don't know what mind reading they want us to do. But okay, so I did get a question about what is the complexity of this, right? There's for loops, this is O of n, the n inputs to index, this is O of n kind of, so why is this not n to the n? Why is this 2 to the n? Yeah, and the reason is just, I think the first way to be convincing, and this is it, right? So the first way to be convincing is just to visualize it out, right? So for example, let's just say let's just say word dictionary is equal to like A. So basically every possible case, right? ... And S is going to be equal to S is equal to . So basically we want to create one for every space, something like this, right? So then now if you kind of just write it out, then now we have construct 0, right? And then the next thing is going to call construct 1. There's some stuff in here. The current stuff doesn't matter, so I'm just going to write ... on it. And then now it's going to be construct 2, and then ... right? And then now as part of this loop, now it goes straight to construct 2, right? And then now it goes to construct 3, ... right? So why is this 2 to the n instead of n to the n? This is a little bit of the tree. Another way to kind of, if you realign this, right? If you realign this, like maybe do it in another way, then you kind of write this as, another way to think about this is, let's say we move this, and there's a lot of ... dots here, but I'll just use this as an example. We move this up here, right? Okay, what does that do? Nothing yet. But then now we align it here, and then maybe we go, oh, this is skip 1, right? And this isn't really a function, so I don't know why I wrote it in this notation. But then now you can kind of think about it here. Now for 0, we skip, and then we construct, and so forth, right? And here you can, in the same way, it goes construct 2, construct 3, but there's also a implicit skip 2, construct 3, right? When it goes to 3. I mean, it's not quite, and once if you write it that way, and kind of reordering in your head, then now for each core, you have a skip and a tick and a skip and a tick, and it goes 2 to the n, if you kind of think about it that way. Another visualization that you can do is just, so this is one way to visualize it. There's another way to visualize it, is that if you look at this, right? And this is basically saying the same thing. I'm basically saying the same thing because it is the same proof, but it's just a different visualization. Is that, okay, let's say we have this gap, we have the first space. Do we want to add a space here? Right? And then if the answer is yes, then we go. If the answer is no, then now we go to the second one. But keep in mind that if we had one here, that means that, again, there's no space here on the first thing, right? There's no space here. So, and then now if you do the count, there's only going to be there's going to be n minus 1 spaces or possible spaces, and well, each of them can be tick, no tick, so it's 2 to the n minus 1, right? So that's basically the visualization, basically the idea. You can think about it in any number of ways, but that's the tighter bound. And keeping in mind that 2 to the n is, O of 2 to the n is in O of n to the n, right? Because, if you draw the curve, n to the n is going to be bigger, so therefore it is the big O. So technically it's correct, but it's not the tight or it's not as tight as it is, right? Though technically I think it is O of n to the n, but whatever. Anyway, that's pretty much all I have for this one. Let me know what you think. Thanks for watching. Yeah, I'll do the other problem after the Rangers game. So stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.